Hello, everyone. I'm Michael Johnson. I'm the PTL of OpenStack Octavia, which is a network load balancing service in OpenStack. So if you're in the wrong place, now's the time to run for the door. I'm on Freenode IRC. We have OpenStack LBAS as our channel. So if you need to follow up with questions, we're there. I'm on the West Coast in the United States. I'm from Oregon. That's the best time to get me, but we do now have cores in almost all the time zones. So if you do have questions, there's usually people around. Mic fell. Okay. So this is kind of our introduction slide. We do this on most of the summits just to give you a little information about the project in case you're new. So Octavia provides a scalable, on-demand, self-service load balancing API and offering for OpenStack. And it's technology agnostic. So we're an API, and there are multiple drivers behind our API that allow you to use vendor or third-party plugins behind our API. We have a reference load balancing driver, which is in tree. That was previously what we called the Octavia driver behind Neutron LBAS. We've kind of renamed it. Octavia will still work on our API, but we've kind of renamed it M4 to try to remove some of that confusion about what is the project versus an implementation behind it. We were founded during the Juno release. There are 3 of us here today that were part of that kind of founding team. It was a partnership between Blue Box, HP, and Rackspace initially, and a couple other companies involved as well. For Queens, we had 90 contributors from 30 companies contributing. We are growing as a team, which is really good in the current climate and some of the projects. In Okata, we moved from being a Neutron sub-project. So when we started, we were a StackForge. StackForge still existed at the time. So we kind of were associated with OpenStack. We could use the infrastructure, but we were developing in parallel to OpenStack. Then we moved into being part of the Neutron Stadium as a sub-project of Neutron. We lived there for quite a while. And then in Okata, right around that time, Neutron decided the stadium's too big. And so they started what they called the Stadium Evolution project, which kind of looked at different components of Neutron and looked at things that needed to spin out or things that needed extra resources to come up to speed. And we decided that we were a candidate to spin out. And we became a top-level OpenStack project. And continually on the user survey, they haven't released an April user survey in 2008. They're changing the cadence, so there isn't one of those. But in 2016 and 17, we're the #1 piece of Neutron that people are interested in, either using or interested in network load balancing. So to give you a little overview of what we accomplished in Queens, it was a busy cycle. A lot of the work we did in Queens was foundation for what's coming in Rocky, so you'll see that a little later as well. We've spent a lot of effort on the Octavia dashboard. So there's been a number of enhancements to the dashboard, and we're continuing to invest in the dashboard. Dashboard is our plugin for Horizon, in case the terminology is confusing, but it's the web UI. So we've added tab navigation. Before, it was pretty confusing how to drill into pools and get down to your members and enable and disable. So we've switched that, fixed that into more of a tab navigation flow. And we've pulled a lot more of the settings into the UI. So the workflow is still pretty similar. We have exposed more settings in the workflow, which is kind of the easy user setup a load balancer workflow. But then when you go into the details pages, you're going to see a lot more of the feature set exposed to the web UI. And then one of those features that we added, which is part of the base features for Queens, was adding alternate member monitoring ports and IPs. So before, you could only monitor the IP and the port that you had as your member. Now, for each of those members, you can define an alternate port and IP. So if you have a separate health page or something like that with your application, we now support that all the way through the system. One of the use cases we're seeing a lot more of with Octavia is Kubernetes and some of these automation tool sets that do quite rapid changes to the environment and topology for scaling reasons, et cetera. So heat, Kubernetes, Terraform, those sorts of things. So one of the cool features that was added in Queens is batch pool member updates. So now you can do add, change, or delete all in one API call for all of your members of a pool. So it simplifies the number of round trips you have to do with that interaction. And that complements our one call API for creating a load balancer. So we still have the single call create, which allows you to create a completely populated load balancer in one API call. So those are both features we're trying to target to people that are doing high rates of change with their load balancers. Neutron QoS support on the VIP. This was a request from a particular provider. Folks wanted to make sure that they didn't go over a committed rate on their load balancers as part of a billing control mechanism. So now you can create a Neutron QoS policy in Neutron and apply that to the front-end virtual IP of your load balancer, effectively limiting the rate of traffic you can put through your load balancer and your VIP. So that's great if you want to work on controlling your spend and your burst rates. Then some other work we did around the TLS offload capability is, again, trying to align to some of the new technologies that folks are using. So we got a lot of feedback that Vault is a technology that people want to use for HSM and their secure content store. And so to support that and drive that, we added support for Castellan as an alternative to Barbican for your secret store. And so you can put Vault behind Castellan and store your TLS offload certificates and keys in a Vault environment. And as part of that work, we switched over to having an alternate way of storing your keys and certificates using a PKCS12 format container for those, instead of a Barbican kind of custom container where you had to create the Barbican container and add your certs and keys. You can now just upload one PKCS12 and do it in one shot. Other work on our OpenStack client plugin, we've enhanced the filtering, so now you have that kind of rich. You can pull out columns, you can filter your list results by specific names or project IDs or however you want to do that. And we announced the deprecation of Neutron LBAS. And I've got a couple slides. We'll talk about that, the status, kind of why we're doing it, and where we're going with that a little later in this presentation. In Rocky, so this is what's under development right now. As I mentioned, we've got a lot of stuff going on that's going to land, which is kind of cool. So first off is provider driver support. So this allows those third-party drivers to be a native piece of the Octavia v2 API. So Neutron LBAS had driver support from a number of companies. Since we're moving away from Neutron LBAS to Octavia, we need to have that support in Octavia. So we worked with our vendors, built a spec around kind of what they were looking for and some of the things they wanted out of that interface. And that code is up for review and merging as we speak, and will be a deliverable for Rocky. So hopefully our vendors will get busy and start writing their drivers. It's a very simple interface. It should be pretty straightforward for you to take a Neutron LBAS driver, take that interface with Neutron LBAS and switch it over to this new interface. The one gotcha that some vendors are going to have is now you're not living as part of a Neutron core service. So if your driver was doing dirty things and going into the database and manipulating the Neutron database directly, you're going to have a little more work when you move that driver over. But that was really a bad habit anyway, and led to issues with Neutron changing the database for like versioned objects and breaking some of the drivers. So that's planned to land. Most of that development work is now complete and it's under review. Next up is UDP protocol support. So we had an operator that really had a good use case for this. We sat and spent some time at the PGG, went through what that use case is and how we can implement that. And so this again is also up for review and in its final stages of review and will land for Rocky. It's pretty basic UDP support. We'll have a couple load balancing algorithms there. We'll have single packet support as an option there for session persistence or not for those flows. So that's work in progress, coming along and will land in Rocky. One highly requested feature, listener timeouts. So this allows you to tune your client connection to the VIP, how long that'll time out with no traffic, your connection to the backends, no traffic. We've also got some deep TCP inspection flow timeouts in there. If you're doing some interesting flows using the TCP protocol, but actually doing HTTP inspections, you can now set those timeouts from the front end. Previously, this was something the operators had to tune in a template file by hand, but now we're exposing that per listener through the API, and so end users can tune that as they need. So that's a great one. That has all landed. Support for backup pool members. This is also known as sorry servers on some products. So this is if all of your backend pool members are down for some reason and not responding to requests, you can define yet another member or endpoint as kind of your sorry page. And so when all the primary members of the pool are down, traffic will get directed to this backup member in that case. That is a landed and supported feature already. Tempest Plugin. So this has been a lot of work. When we started Octavia back in Juno and Kilo timeframes, Tempest was migrating how you built your Tempest plugins. And so we've kind of had this rough journey to today. Originally, your plugins were all living in the Tempest repo, then you had to have them in your repo, then there was Tempest lib, then there was the other Tempest lib. So it's been kind of a moving target. We've spent a lot of time this cycle making sure that we have a really good story for our Tempest plugin. It's now a separate repo that'll be testing the V2 API, which is our Neutron LBAS compatible API and our go forward API. So those are also landing as we speak. And those are all now up to speed with the current Tempest specs for how you write plugins and how you test your framework. So that's API and scenario testing. If you do have questions about the testing, I am doing an onboarding session later today. We will go into a little more depth of how we test Octavia and what those different types are. Tempest, functional, unit, grenade, all of that. I'll cover more of that in that session later. So again, pulling some more features into the dashboard. So we have now full L7 support, so you can do your L7 rules and policies through the UI. That's not part of the basic workflow. Again, the workflow is to make it easy for new users, but when you go into the details page, you can now add these to listeners and do all of the L7 policy and rules that we support through the API on the GUI. So that's really nice. And then the header insertion, this is the X forwarded for headers. If you want those, that is actually part of the workflow, so you can check those on as you create your load balancers through the GUI. One of the other features that I've been itching for a long time, but there were some gotchas in Horizon that were holding us up, is the auto refresh. So this patch is up for review. It's already got a +2. It's also going to land for Rocky. It will now dynamically update your pages in our plugin so that you'll see the live status, both operating and provisioning status of all your components. And so when something changes behind the scenes, you'll see it update in Horizon. Depending on how I do here and how long I talk, I may have, show you a demo of that. I have a video recorded that shows some of these new Horizon enhancements. So if I'm long-winded, no, but if not, I'll get to it. Under development right now is the Neutron LBAS to Octavia migration tool. We want to make sure we have a clean way to migrate running load balancers from Neutron LBAS into Octavia. This is intended to be a live migration. We will not require downtime on the data plane for this migration. Essentially, this migration is all database work. It's going to be pulling objects out of the Neutron database, moving them over into the Octavia database. Our data models are very similar. Of course, Octavia has more features and has additional things that can be turned on, but we should be able to move over pretty cleanly. And then the other pieces, we need to go in and tell Neutron, Octavia now owns these ports and components of our environment as opposed to them being owned by Neutron LBAS, because they are currently two separate project paths. So this is under development. There's a stub up posted now. It's not functional in the least, but this is something we're really committing to do in Rocky, make sure that that's available for folks to use. Upgrade testing gate and OpenStack upgrade assertion tag. So as I mentioned earlier, grenade, this is something we haven't had until now. We now have a patch up that is running a live upgrade from Queens to Rocky, and will become a gate. This is the first phase. There is a path to do a zero downtime upgrade. We know you can do it, but to actually claim that and get the assertion tags, we actually have to put gates that do that in place, and we're working towards that. So in future releases, you'll probably see us keep working up the upgrade tag path, but in Rocky, we're expecting to have the initial upgrade tag asserted for our project. Some other enhancements, we spent some time working on the AMP image size. So the QCOW size that's stored in Glance. The distributions have been growing over time, and I'll look at the guy in the orange shirt and give him a side glare. So when we started out, our QCOW was 300 meg. Now, after these enhancements, we're at 5. And this last week, we actually had a problem that using Disk Image Builder to build our image during build is tipped over 2 gig because of all the packages that are cached and all that stuff. So we had to make some enhancements there. So now we're building Ubuntu using the Ubuntu minimal element in Disk Image Builder. And that has shrunk our size significantly, which is really good. And then Red Hat did some enhancements as well, where they moved over to using some of their packages. So we don't have to pull in as much pip Python packages and even have to build some of those, which we had to do in the past. So both of those have shrunk their image sizes. I will give you credit, Ubuntu still has the win on the smallest image size. So at the end of the day. 2 other items we're working on, and frankly, these are at risk for Rocky because people contributing to them have had some side projects going on internal to their companies. We're going to really try to get these into Rocky, but it's not clear that they're going to land like the rest of these are. So flavor support, this is similar but different to flavors in Nova and Neutron. This is a really rich metadata architecture that allows you as an operator to define flavors for load balancers and expose those to those users. And this goes beyond just the configuration of those load balancers. It also allows you to pass custom metadata to those third-party drivers. So let's say there's a vendor, Acme Inc. I don't want to call any particular vendor out right now because I don't see any of them in the room that I recognize. Let's say they had a golly gee whiz mega encryption feature for TLS that we don't have exposed through our API, but they want to make that available to operators. If their driver has support for that in their metadata framework for flavors, the operator can define a flavor and put that metadata in and allow that flavor to use that custom functionality in their device or appliance until we add it to the API. And there may be some features that are just purely vendor specific. We're probably not going to put tickle code into Octavia. There's one vendor that uses tickle code still for some of their rule set. That would be a perfect candidate for putting into a flavor definition and making that available to your end users if you wanted to. This is mostly here. There's a full approved spec for it. There's stub code in for it, but it's just not 100% clear that we're going to make the Rocky deadline, so I don't want to commit to that because we don't have patches up for review yet. And then active, this has been a long journey for us. There are 2 drivers in flight right now for active. One is what we're calling the L3 driver, which uses BGP advertisements to a top-of-rack piece of equipment that has ECMP support with persistent or consistent session persistence in it. And then the alternate driver is an OVS-based OpenFlow driver, which would be a pure open source solution, which puts a distributor VM, well, pair, in front of a number of traditional Octavia Amphora. Both of those are in flight. Both of those have patches up to some degree, but both of them still have some work to do to land. And so it's just not clear to me that we're going to be able to make that for Rocky. It is a priority for both of the companies that are focusing on these. It's just competing priorities, and it keeps getting bumped. Both have done proof of concepts. I mean, we know they will work. It's just getting the resources to do the dev on that one. Let's move on. So beyond Rocky. I do have a roadmap published up on our wiki that does have future things we want to work on. We're always welcoming additional features that people are looking for, but these are some of the things that are kind of on our short list we really want to do. So once we get the active in, and that's kind of our first step, the second step and the second spec that has been approved is for auto scaling. So taking that active collection of load balancing components, and then looking at the statistics and deciding on how to expand or contract that pool of load balancers based on the load. Again, we have an approved spec for that. We know how to do it. It's just we want to incrementally do the work and balance out the resources we have to do development. Log offloading. This is an important one for a lot of us. For some people in the room, it may be not an important one because they're just turning off logging to get around the new compliance regulations in Europe. But this is being able to get your flow logs out of the Octavia driver elements, so you'll actually see your flow connection logs and make those available to your users. We have ideas on how to do this. This might slip in to Rocky. I know there's somebody that's interested in working on that. But essentially, we'll have a way that we can offload those logs up to the control plane, and then you guys can decide how you want to direct them from there in your deployments. TLS cipher and protocol support. Right now, that's kind of a fixed set and defined at your installation time. We do want to expose this because some customers do have specific needs to restrict their VIPs and their termination to specific ciphers and protocols. So that's something we'd like to add. And of course, back-end TLS re-encryption. So today, your incoming VIP, we have full TLS offloading, but on the back end from the load balancer to your back-end members, that's unencrypted only right now. Again, that's just extending the work we've already done for the front end to the back end component and adding that API capability. Yeah.
So doing OpenStack, so is there a way to manage the ciphers that you're making available to Octavia? So we have certain ciphers that we only want to expose to the other ciphers?
Yeah. So right now today, that's something the operator has to do by defining a custom template. So we have Jinja templates that are used to configure the load balancing elements. And so you can go in and modify that template on a deployment-wide method. So you can do that by hand today. What we want to do is expose that via the API and allow people at creation time to define those. Health monitor content checking. So today we're pretty simple on our content checking for HTTP. We basically look at your status codes that we get back and decide if it's healthy or not. This is taking that a step farther. We have the capability to do regex. We just need to expose that through the API. So you can define a regex that says, yes, that member is healthy or not based on the traffic. Again, mostly API work that needs to be done to enable that. And health monitor protocols. So in a previous release, we added capability that was originally documented but not implemented, which was ping. There really isn't a good use case for ping other than testing as a health monitor. Just because the machine's up doesn't mean your app is, so you really want to use ping that often. In fact, there's a disable option in the config file that lets the operator say, no, I'm not even going to let my users do this. But when we added that, we added kind of a framework to allow adding additional health monitoring protocols. So we can expand the list of supported health monitor features. So right now we do TCP, ping, HTTP, TLS handshakes, and I think there's one other in there. But this would allow additional things like MySQL or things like that that you may want as a health monitor protocol.
But if you already disable the TLS re-encryption, when TLS handshake?
We're not actually establishing a TLS encrypted channel to it. We're doing what's called a TLS hello handshake. So it's a piece of the protocol that allows us to actually go out and start the TLS negotiation and validate that it's actually up. Right. When we have back-end re-encryption, of course, we could have a full handshake and then a content check behind that. Yeah. Yeah. This is something that we've been working with Firewall as a Service on. It's something that folks have wanted, particularly in the Kubernetes space. The question is, how do we create security groups on the back end, so that your back end connection to some other OpenStack entity are a member of a common or an accepted security group. So in other words, you may have a web server on the back end that you only want the load balancer to be able to access, not anybody else. So right now, to do that, you have to create a tenant network that's isolated basically and has no access. This would be adding a security group that applies to those back-end connections that gives you a little more flexibility of who can come and go from those back-end servers. It's something that we need Firewall as a Service to have a shared group concept. I know that's work that's in progress, but that's something that's on our roadmap as well, is solving that back-end network security question in a better way for our users. And then, of course, beyond Rocky, Neutron will leave deprecation cycle and go end of life. And again, I have some slides to talk about that here in a second. See how am I doing on time. So here's that talk. My timer didn't start. So in Queens, we declared Neutron LBAS as deprecated. There are a number of reasons for this. In fact, we have an FAQ posted on the wiki at this link that'll talk about it in detail. It solves a number of deployment issues for our operators. Neutron LBAS has some fundamental flaws in it that would essentially require a full rewrite to resolve. And that's what we were doing with Octavia anyway. Most notably, if you're doing that high rate of change through the API, some of the database locking and object locking in Neutron LBAS is not correct. And so there is a chance that you can do a high rate of change against your load balancer, and you may end up with members that don't actually get created. So those are some of those fundamental problems. We also had some performance and some features that being behind Neutron limit us from doing. So that was another reason behind that. The deprecation, what that really means right now is we're not accepting new features. So we're not going to allow anyone to post feature updates to Neutron LPAS or expand the capabilities of it. We've kind of put a moratorium on that. But we are continuing to accept bug fixes, and we will do bug fixes on the project into the foreseeable future. Standard deprecation, which we do have asserted as a tag and we will follow, means that we will not make Neutron LBAS end of life for at least 2 cycles after we declare that clock starting. And so that would mean a year after we say, okay, the deprecation clock's starting, Neutron will still be supported for bug fixes. Beyond that, it's going to go into that extended support that you may have heard of this morning in Keystone, or at the keynotes. And that would mean other folks would still have to support it and integrate those bug fixes. It's not clear that we will, for sure, merge those bug fixes. We have not announced when that clock's starting yet. We want to make sure that we have everything in place in Octavia so that it is an equivalent, service for you guys. At this point, and I've got a slide. The next slide will talk to us a little bit. We're getting pretty close to having that full capability in place. And then we'll announce that we're starting the clock. The other piece of that I'll mention is it's a minimum of 2 cycles. That doesn't mean it's going to be just 2 cycles. If we need to, we may end up extending that a little farther. Just depends on how the community reacts and moves forward, particularly in the space of drivers and migrating. So the facts there, please take a look at that. If you have questions, it's quite a bit of information. I took some time to write that up to help people understand what's going on and what's available. There is a pass-through proxy available right now. You can install that in Neutron, and that will proxy requests from the Neutron API straight through to the Octavia API. So this is a migration tool you can use in your environments. You can also do something similar using L7 policies on your API load balancer if you want. Basically, again, taking our URL path and passing it off straight to the Octavia API. Just again, a reminder, the Octavia v2 API is a superset of the LBAS v2 API, which is what Neutron LBAS implemented. So you can essentially take a command, change the endpoint, it's going to work against your Octavia API. And we've done a bunch of additional testing and validation against that to make sure that that is something we can truly say. So as I mentioned earlier, the live migration tool is under development. That's in plan for Rocky. With that will come documentation about how to use that tool and the migration and what it means to you. The live migration, again, is going to depend on the driver, assuming their driver can talk to the same backends that they have running under Neutron LBAS, which there's no technical reason they shouldn't. You should be able to do live migration. And once the provider driver support's completely landed and the migration tool is complete in the documentation, then we're going to consider starting that clock. And right now, we're on track to do that in Rocky. Cross-project work. So still looking at how to use containers. We want to use containers for our Amphora images, our service VMs, but we've run into a lot of roadblocks. There's a lot of bugs. The community support has been challenging on some projects for that. We do hot plug networks. That's one of the big gotchas that we keep running into is being able to hot plug those user networks in and out. And maintaining the consistency and the uptime for flows going through the containers. It's been one of the other issues. So still looking at that. I mentioned the firewall as a service integration. We are working with the Keystone team on default RBAC rules. Unfortunately, that session's going on right now. So I gave Lance my input, and we're going to continue talking about that. Octavia is one of the leaders. We have advanced RBAC policies by default now. So you have rich member, observer, auditor kind of roles on by default. You can turn those off with a policy file. It's really easy. And then we're also highly involved in the discussions with Neutron about the end of support for IU and how we're going to do our open flow controller work. So feedback, Q&A at the end, though it does look like I talked a little while. Again, we're available in OpenStack LBAS. That's our IRC channel. We are very welcoming. We are here to help you. If you run into deployment questions or anything like that, please come to the channel. There will be people there that will help you and walk through debugging. We do have weekly IRC meetings in that same channel. And you can get us on the developer mailing list with this subject prefix. And we are one of the projects that has moved to Storyboard for our RFE and bug tracking. If you're not familiar with that, the Foundation's moving all projects to Storyboard off of Launchpad, slowly one by one. And we are one that has taken that plunge already. So if you do need to open a bug or an RFE, that's where you go. Same thing to contribute. We are looking for developers, code reviewers, especially. We have a backlog of code that needs to be reviewed. Plus ones, minus ones matter a lot to us. So please feel free to do that. There's lots of work to do, bug fixing, open flow development support. Not all of us are experts in that space, but we need to leverage that. So we are looking for people to help us with that. Of course, API feature enhancements. We mentioned a number of those, and Tempest work that's going on. And of course, if you're a vendor, please contact us. Let's start talking about getting a driver set up for you guys on the Octavia native API. And there's an onboarding session later today. So any questions? I think we have just a few minutes for questions.
Do you have a demo video?
Yeah, I don't know if we have time for that. But I'm happy to meet people in the hall if you guys want to see the GUI.
Question about the open flow. So, because my understanding is Octavia, all the work nodes are based on VM. So, where is it only this open flow is got involved because of security, mostly the security?
No, what we want to do is for our active-active, so to improve the performance. Okay. So we kind of want to implement logically what you consider a load balancer of load balancers. And so the way we're doing that in the OVS driver option, because there's two active-active drivers, is actually doing open flow control of an OVS implementation. So that's our pure open source option for active-active.
Because active-active, you could also consider, I guess, provision your load balancer VM in a different zone, similar to what AWS is doing right now. They always, by default, give you a pair.
We have that support already. We've had that since Mitaka. That's active standby. Okay. But this is horizontal scale. So this is 10 Amphora service VMs behind to be able to scale out. And that's where we want to have as low into the switching infrastructure of the operator as possible to make sure that performance scales up. That's the real driver for the OpenFlow. I'll start here. And
I'm just wondering why you don't consider the BGP-based active-active as open source. Is it just because of the reliance on top of rack switch, or?
Yeah.
Okay.
Yeah.
Is there more?
It's just a terminology I'm used for like pure software runs in our test gates kind of thing. There is some discussion of using some of the open source BGP implementations as a test framework for that. It's just not implemented.
Right. And who are the people behind that, just out of curiosity?
So primarily Walmart's driving the L3 implementation.
Okay, thanks.
So, hello. So I have two questions.
Sure.
The first one is about Enfora. I want to know if, like, depending on the workflow, not the workflow, the workload on Enfora based on HA proxy, if I'm correct.
Yeah.
If you need to isolate your Enfora image from the rest of your production to avoid nosy neighbor scenario, if you have a preferred way to do that.
Yeah, you would handle that just like you would handle any other compute instance in your environment. So you can put restrictions around that using your Nova flavors or whatever you're using for your virtualization container for the VMs. So I don't know if you're in Zen or KVM. You can put restrictions around that and make that a part of your Nova flavors that all of the M4 are built off of. That's one way to do that. You could also build a custom image and put other restrictions inside that service VM image if you wanted. Those are two options. Today, we don't have anything built in for limiting that.
And the second question is, what's the preferred tool for deployment and upgrade for Octavia?
You're going to get me in trouble with the
Yes,
distribution vendors, aren't you? OOO is an option. OpenStack Ansible is an option. Cola Ansible is an option. There's support for Octavia in a lot of these deployment tools. At Rackspace, we're an OpenStack Ansible shop for the most part. But Red Hat, you heard earlier OSP 13 is coming out. Octavia is a fully supported piece of OSP 13, and that's based on the OOO deployment.
Thank you.
Hello. Do you have the plan to support different kind of topology in the same Octavia deployment?
So different drivers?
Different topology, for example, our customers, maybe some of our customers are willing to use the single topology for load balancer. Some other customers want to use the HA.
Yeah. So right now that's a config file setting. That is what flavors will support and enable you to do. You'll define a flavor that is single or active standby or active-active or a vendor driver. That's the intention of flavors, is to allow you to expose that to end users.
Okay. By the way, there's one thing I want to advertise, that if people here are interested in the Kubernetes on top of OpenStack, there's an ingress controller deployed by myself for Octavia. I think it's better choice than the Nginx ingress controller or other options. Yeah.
I think there was a demo of that at the keynote.
Sure. Yeah. Okay. Yeah.
Oh, it was the load balancing type he was using?
Yeah.
Okay.
Thank you.
Yeah, thank you. Other questions? I know we're got 1 minute left. Probably should wrap up. If you do have additional questions or you do want to see that video, I'll just step out into the hallway and we can take a look at that on the laptop and I can talk through that. Thank you.